Hey guys, thanks for watching. Today I'm going to be going on about the three relay cooling fans on a lot of GMs, some Fords, and even some Dodges. They use three relays, a main, and then two relays, one for each fan if it's a two fan system to control the high and low speeds. Now, I've actually drawn out a schematic about how this works, and I'm just going to be going over the low speed for right now, just in case anybody has any problems with that. How the low speed works is you have both your lines, which are hot all the time, and I tried to draw all the positive up here in blue, and then all of our grounds in black. I don't know how well it's showing up, but how this works is you got your power feed coming in, and it goes through two separate fuses. You'll have your cool fuse or cool fan fuse 1 and cool fan fuse 2. And what it does is it will flow through the fuse if it's not popped. Um, for the low speed, you don't even have to have uh, the cool fan fuse 2. It will go and it will flow. This is hot all the time. It will go into the cold side and into the normally open part of the relay. The computer, the PCM, actually grounds this to turn it on, depending on if you got the air conditioner turned on or if it reaches a certain temperature with the coolant sensor. It will close this, which then allows it to be grounded. Whenever this is grounded, it will enact this electromagnetic relay to snap this normally open position relay shut. So this is open all the time, and then whenever it shuts it, it allows the electricity, the 12 volts, to flow through it and come down and go into the left fan motor. Well, it goes through the left fan motor, and instead of being grounded, it keeps on coming over and goes up, and then it goes into your main relay. Now, your main relay is a 5-pin relay. It has a normally closed and a normally open position. When this relay is not energized, the normally closed lets it flow through it, comes down, comes over. It makes it over here to your relay number 2, your fan relay 2. And since it can't flow up and through this relay because it's open as well, it goes back down and goes into this second motor and then out into ground. So these motors are both wired in series, and they're each getting 6 volts apiece, which lets them run at half speed. So in order for this circuit to work right, you must have a path here. This fuse cannot be popped. It has to be in the vehicle. Over here, it doesn't matter if this fuse is popped or not. It doesn't matter if the relay number 2 is not even in the vehicle. But what does matter is this relay, and this relay must be in the vehicle and in the normally closed position. If it's in the normally open position, then it will try to run at high speed. But I'm not going to get into that in this video. We're just going to be doing a few simple checks with this and just showing you how to troubleshoot it. Both fan motors should be running and running at a low speed. And how to check this is get you a test light, make sure you get on a good ground and that you keep that good ground. And then with this fuse box under the hood, you have a diagram, or should have. And on that diagram, you have fuse number 1, which is all the way down here in the lower right corner, which would be your cool fan 2. That's this fuse here, the one I said didn't matter. And number 6 is your cool fan 1, which is the one that does matter. It's also a 30 amp. So it's this fuse right here. So take your test light and make sure that that fuse isn't blown. Now, it has to go into this relay, and with this fuse removed, you won't have your coal side 12 volts or the 12 volts on the normally open side of the relay. These relays and how they work is they crisscross. So your coal side, I believe, 85 and 86 is your coal side. That's the side that draws in the contacts in this relay. 85 and 86 draws 30 into 87. So whenever this is energized, 30 will be hot, and then it will get drawn into 87, and that allows the voltage to flow through just like a light switch. You'll look on the bottom of this, and it's got 4 pins, but it actually has 5 different terminal locations written on it. The 86 and 85 is right here. And I was actually wrong. 85 and 86 is this side and this side up here. So this side and this side here is your switch side. So with the fuse in the vehicle, and we've already checked the fuse, we'll go ahead and check this coal side out and see how we got power on one side. The other side is grounded by the PCM. It's not being grounded right now. Right now it's just an open circuit. But with the vehicle running, and like I was saying about the air conditioner and the coolant sensor, it will actually ground it to here, and then that allows this relay to close and make these contacts close as well. But you should have power on this, and then to check your switch side to see if you're getting power there as well, because that fuse powers both sides. It should be, yeah, it's right down here, so they're right next to one another. So this side right here has the power on it, and what it does is whenever that relay closes, it sends the power through here, and that's the power going to your fans. And I can actually demonstrate that for you with a couple of test pins. And you can use paper clip, whatever, just make sure they're not too big to go down in these little slots, and you do not want to spread these open or cause them to be pushed down in, because if you do, your relay's not going to make a good connection and you'll run into problems. These fuse boxes are not cheap either. So let's look at our relay one more time and be very careful whenever you're doing this. You do not want to ground the coil side. You can damage the PCM. Try to get it focused. 85 and 86. And it doesn't matter which way you put this relay in, because if you flip it over, 85 and 86 is right here and right here, right? So when you flip it over, you still got 85 and 86 on the same side. So 80, 85, and 86 are these two terminals. So 30 and 87 are these two. Right here, and not shove it in, and up here. Just to test this, get you a jumper wire. Just make sure it's not going to fall out and ground on anything. And the same thing over here. And they should both kick on and run. Now the problem that I was having was I had one fan coming on, and it was the smaller fan over here. And I had to end up chopping these wires. I'm gonna fix this a little better later on. But for now, I had to end up chopping these wires. And give me just a second to get this connector loose. It's a little rough to do sometimes. You pull that out, and then there's a little tab here, and it's going to take both hands to pull that out. You pull up on this, and then it slides right out. See how it clips down over this, and then that little blue lock tab, it fits in that little slot, and that just keeps everything pushed together in case this ever was to get loose. But see what happened now? And what happened was this actually got loose, and when it got loose, the fan would kick on and run sometimes, and then sometimes it wouldn't. And I didn't know at the time that there was actually something wrong. I've never looked at the schematic of how the fan motors work on this. I know that this fan over here would kick on and run, and then this one over here would kick on and run with this one. But then this one would kick back up, and the way it was doing it, it looked like it was supposed to do it that way. And finally, once it burnt on it too, then all I had was this little fan over here, and it was just running in high speed only. So my motor was already overheating by the time this fan would kick on, and it wasn't enough to cool it off. I actually had to pull off side the road 2 or 3 times to get it cooled off to where I wouldn't have any problems with the blown head gasket or anything. And I don't know if you guys know anything about the 31 and 3400 engines GM built, but they're notorious for head gasket leaks, intake manifold gasket leaks. So I definitely did not want to overheat this. But the way this circuit works is for these fans to both run and to run right, they must both have a good connection to them. To run in low speed, they run in series like I was showing you earlier. And if you don't have a path to get it on through this motor and get it to ground, then this one over here is not going to run either. They're both going to not run. And then it's going to just keep heating up and heating up until you hit the high speed where they both actually separate out and they're both getting the 12 volts that they need. And now see, whenever it goes into high speed, all 3 of these relays close. So it's going to flip here, and flip here. And when it does that, then you are getting 12 volts up. But instead of it going over to here, it's going to go on up to here. And when it goes on up to here, it's automatically getting grounded. So this one is getting its own 12 volts, and then this one over here is getting its closed, so it's going to run through and down, and then it's got its ground as well, and that's your high speed. And the computer tells it to run at low speed, different temperature ranges for different vehicles. I think low speed on this one is 220 or 218, something like that. And then high speed is actually 230, which is way too high anyways. Bigger fan. And then these two right here is for that smaller fan. They're gray and white. And they go down into this connector. But then they each have their own connectors right on the motor. And let's see if I can get that off. You may need to check there as well, is what I was going to say. And just be really careful with these clips. They're exposed to a lot of heat, and on this van, a lot of age. I read about 1 ohm. But as you can see with the smaller motor, I was reading about 0.9 to 1 to 1.1 ohms. On the larger motor, I'm reading 0.6 ohms now. And it was reading 3 ohms with that bad pin on there. It wouldn't allow it to work. But if you got a fan motor on either side, depending on which motor it is, it's not working. It will cause the other one not to work as well, depending on what speed it's running at. So with the left one, the smaller one over here, I know it's to my right, but if you're inside the vehicle, it's the left. So if the left motor is working, but the right one is not, like I had, you will not have a low speed if you have a problem at the right one, because you just don't have a path for it to get to ground. It will have to kick to high speed. That relay will have to close, and then it will go to ground. Other way around now. If this fan's working and this one is not, depending on what your problem is, if it's wiring right through here between this relay to this relay or at the fan itself, you're not going to get the 12 volts, divided by 2. So you're not going to get power down to this motor. It's not going to work. Now, once the high speed kicks in, it will go to ground. So if you're having problems with one or the other, you're not going to have a low speed. All you'll have would be a high speed. Right, I'm going to go ahead and start the vehicle, and I'm going to show you guys how to check these fan motors. Both. Just turn your AC all the way up. If you got back controls, if you're driving a van, turn it on too. And then take your test lights. Make sure you got a good ground. And then once the pressure gets high enough, See how we got the lights lighting up on this side. Take your test lights now and put it on the other side. And you'll have your other as well. I'm going to let this come off some. I spilled a little bit of antifreeze earlier and had to rinse it, and it's pretty strong. But you seen how I plugged the test light up to the positive and then got on the white wire and it lit up as well. Well, that lets you know that your ground a coming. That lets you know that your ground. See how it's grounded all the time? That your ground is good to go onto this one. And then this lets you know that your power feed are coming from this relay. The cool fan relay 1 is good as well. So we got a power and we got a ground. So there's no other reason this motor shouldn't be working. Now as for the other one, now remember I had to chop these 2 wires, but we can still test it even though I had to use butt connectors and hook it up to this. We can still test it right here on this plug as well. And really, you can do it on the other one just to make sure you don't have a problem from here, or actually from here down to there as well, which I don't, but it's really good to show you guys both ways of how to test these, because if you got power going to it, then you should have a motor running. I think that stuff is just about evaporated off. Now I'm still on the power side, so what we're going to do on this one is we're going to check for the ground first this time, then we'll check for our hot 12 volts. We'll go ahead and turn it back on and leave the AC turned up. And it shouldn't take it long with the AC turned on because the pressure builds up pretty quickly. See how we've already got our ground. We're going to go ahead and see if we got our 12 volt feed now. We're hooked onto the ground. Test lights are lighting up. So on this side, and there it is. See how we lit up now? I'm going to go ahead and turn this back off. Well, actually, before I go ahead and turn that back off, we'll go ahead. Remember 85 and 86? Well, on one side of this, we should have our ground. So we'll hook the test light up. And there's our ground. Remember 85 and 86 being our cold side. 85 is down here in the corner. Earlier we determined this side is our hot all the time on both. The cold side and the actual switch side of the relay itself. So this side here, and you see that lets me know that my ground coming from the PCM to this relay is good, and it clicked as soon as I put it in. We'll go ahead and check this. There's our ground on our main. So we know that the PCM is commanding the high speed on as well. And we'll check this. And we got a ground right there. And the way this is, that is 86. If you flip it over, 86 is in this upper left corner. So the high speed is definitely being commanded on all three of these. We checked it and we checked the feed for the low speed. Make sure you're plugged back in down here. And remember earlier when I checked this one and it was 0.6, and I checked this one and it was about 1 to 1.1. Well, where they're wired in series, and what you can do is from here and all the way through into this ground. So we got our ground hooked up here, and just make sure you get on the right pin. Right here should be our path. It'd either be this side or this side, so whichever side you got continuity on. And that lets you know that you have ohms and continuity from your ground through both motors, all this wiring, all the way back to here. 0.6 and 1.1, we have no extra added resistance to it. Now you can check this other side. It's just going to show you the second fan itself. Get a see, and that's just your one fan to ground. Now, in order for you to be able to check, so we've already went ahead, we checked both motors together on the low speed. We checked the cooling fan right, the big fan on high speed. Now, in order for us to be able to check the little one on the high speed, now we will remove this relay as well. And what you will have to do will be, you'll have to close that normally open connection. So we'll close it from here to here. Leave this relay out because you don't want to read both of them together. You want to just read the one by itself. And what you'll do is you'll be right here. You'll go through and you'll go up this way. So you'll go, instead of going through here and going through the other motor, you'll go up to here, over, and then down to our ground. So we got our connection there. We're going to go back up here to right here. I can get my hand up of it, make sure everything's all right. Now everything's balanced out. See, we got our 1.1 to